We treat our smartphones like magic glass windows. As long as we have a cellular signal, we are looking directly into a centralized cloud. But we rarely think about what happens to that window when the connection goes dark. When your device hits a network dead zone, it loses its physical tether to the outside world. Applications built strictly for the cloud suddenly face infinite network latency. They are shouting into a void, waiting for a server response that will never come, which causes the application to instantly freeze. Yet specific applications, like digital field maps or note-taking tools, do not freeze. You can keep typing, swiping, and saving your data, completely unaware that you are offline. Pulling this off places immense technical constraints on the hardware. The device is suddenly forced to process complex data structures entirely on its own, utilizing restricted RAM and a draining battery, with absolutely zero connectivity to back it up. This offline survival relies on a hidden architectural layer called a mobile database. It is a system built to sever a device's reliance on a constant internet connection. A mobile database is a lightweight system that lives locally on your edge device. Embedded, serverless engines like SQLite power local storage. Instead of seeking a network endpoint, they write operations directly to the device's internal storage, dropping straight into that local cylinder. Because the data never has to travel hundreds of miles to a server farm and back, operations achieve zero network latency. The application's performance feels instantaneous because the request only travels a few millimeters to the internal storage chip. This also preserves your battery. Forcing a cellular antenna to constantly hunt for a weak signal consumes vast amounts of electricity. A local database allows the device to batch operations while the radio stays off. During a disconnected phase, the smartphone ceases to be a dumb terminal waiting for instructions. It transforms into a fully autonomous, self-contained data center. Eventually, the train leaves the tunnel. The device emerges from the dead zone and regains its cellular signal. Now it must synchronize all of those isolated offline changes with the master central database server. This creates a core computer science problem known as the sync paradox. It occurs when two remote workers, completely disconnected from the network and each other, modify the exact same centralized record simultaneously. Accepting both offline files causes catastrophic overwrites. To prevent this, developers implement a synchronization gateway. This middle layer intercepts the collision, executing automated conflict resolution algorithms. It evaluates rules to decide which edit takes priority, passing a single, clean master record to the server. These gateways also compress data packets before transmission, ensuring the sudden burst of sync activity doesn't drain the battery. There is a mandatory security constraint here as well. Because enterprise data is physically resting on a portable device, the mobile database must utilize robust local encryption to prevent data exposure if the hardware is stolen. Building for the dead zone requires a layer of intelligence beyond simple local storage, one capable of unraveling a conflicting reality the moment a signal returns. By pairing local embedded databases with synchronization gateways, developers move the heavy lifting of data management from the central cloud to the device in your pocket. This transition defines the architecture of edge computing. In the real world, this means human productivity is no longer tethered to the geographic reach of a cell tower. Data creation continues, whether in a remote forest or a reinforced concrete basement. When this architecture succeeds, it stays invisible. The complex machinery of synchronization and conflict resolution runs entirely in the background, allowing the app to feel as stable as if the internet never left. These invisible engines are the ultimate failsafe, guaranteeing our digital lives never stop, even when the internet disappears entirely.